Alright, here's the chemistry lesson on scientific notation. This is something that you'll be putting your numbers into on a continuous basis if they get too large or too small. Scientific notation just means that we're going to take and not have to write down all of these zeros. So whether we have really big numbers, or here in a minute when I show you a really small number, we can put this into a number that's easy to recognize and to use. This here, 602, and all of those zeros, is actually a mole. This is the size of 1 mole, and we use this continuously in chemistry. But to put this in scientific notation, I have to then be able to change the decimal of this so it's a smaller number and have to write this down, because nobody wants to sit here and count all these zeros. So remember, from math, every number has a decimal point at the end of it. What we're going to do is put this in a smaller form. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. What we want to do is take any number and move the decimal right behind the very first number. We can't get rid of all the numbers, but we can get rid of all the zeros. So we're going to take this and we're going to say, okay, this number is going to be 6.02, because that is where I move the decimal to, and that's all of the numbers that are not zeros in here. So I can get rid of all of these zeros now. Now I move this by a power of 10, so we go times 10, and how many places did we move it? 23. So this great big huge number just becomes 6.02 times 10 to the 23rd power. If using a small number, such as something like this, it's the same process. I want to take the decimal and put it right behind the first number there. So this would be 6.26. I know that I'm going to move it in powers of 10, so I'll start writing it here. That means my decimal now is going to go right here. And how many places did I move it? Well, that would be 1, 2, 3, 4, 5, 6, 7. So this would be 10 to the 7th. But since this number went this direction, or was smaller and not bigger, this is to the -7th. Whereas the last one was a larger number, so it was a positive number. So when you see a number like this, you would then say, okay, that's 6.26, count the number of decimals that's going to move there, times 10 to the -7. This would be the number that you would write down on tests and things of that nature, not this number. This is a very simple little process. Remember, we're going to move the decimal point so it is right behind the first non-zero number. We're going to count the number of spaces the decimal was moved. We're going to write down the complete number with the decimal point in its new location, then write times 10 amid the number of places that the decimal is moved as the superscript. That means the number is up high. And if it was greater than 0, the exponent then would be positive. If it was less than 0, the exponent would be negative. Review this as many times as you need to get this process down, because you'll be expected to have this, be able to do this in class on every exam. Remember to stay gritty and never, ever, ever give up.